discuss about the two fundamentals law, Kirchoff's law, that is KVL and KCL. Before going to discuss about network, which consists of a number of electrical network elements, we are trying to have some fundamental idea. Current electricity deal with flow of electric current that I equal to dq by dt, where that q is the charge, q is the charge, and t is the time, and I is current flowing in the circuit. Now another law we know that is also useful for network proportional to current I, or we can write that B that will equal to I into R, where R is the resistance, I current, and B is voltage. Now this formula or laws is useful for solving any network analysis. Now, depending on the elements, we can consider which is the active circuit, which is passive circuit, and there is other element also there, linear element, non-linear element. That type of element we mainly use in a circuit design. And the three components are very useful to design any circuit. That element is first one is the resistors. These are the symbol of the resistors. Another one is the inductor, and another one is capacitors. Mainly these three components we are used for design. Before we start that KCL and KVL, we must know that what is the node, what is the branches, what is the loop in the circuit. We have to identify in a circuit where the node is start, where we can call branch, and where it is called loop. Now here I draw one figure, and from this figure we can explain what is the node, branch, loop, and mesh. Let's start first definition. What are the node? It is the junction in a circuit where two or more network elements are connected together. That is called node. So as per definitions in this circuit, we can say that there is a four nodes are there. What are the nodes? The nodes is A, B, C, and D. These four nodes are present in these figures. Next one is the branch. What is branch? Is a part of the circuit which lie between the two junction in the circuit. It is lie between two junction in the circuit. So as per definitions, we can say there are five branches here. What are the branches here? Branches is AB, this branch, another is BC, this one, CD, and DA, and the last one branch we can say it is AC. These are the five branches here. Now coming to the next one, that is loop, which is very important to identify the circuit. The definition, it is a closed path in a circuit in which no nodes is encountered more than once time. B, C, that will complete one loop. Another loop is A, D, and C. So as per definition in this figure, the loops are A, B, C, A, D, C, and the last loop, that is A, B, C, D. So there is the three loops in this circuit. Now next it is maze. Now maze and the loops quite uh, easy to identify if we know the definition. It is a closed path or loop which does not contain any others loop within it. Now you can see in the loop there ABC, ADC, also ABCD is a loop. But maze, we can say there is only two mazes there. What are the maze? A, B, C, another A, D, C. We can't say that ABCD is a one loop. Why? Because inside their loop another two loops are there. That's why we consider only these two loops. Now, if we know these definitions, we can easily identify in a circuit what is the node, branch, loop, and maze. Now directly we start that KCL circuit. There is a two fundamentals law in the network analysis. There are Kirchoff's current law, KCL, and other Kirchoff's voltage law. Now in Kirchoff's current law, what it state? It states that in any electrical network, the algebraic sum of current meeting at any node of a circuit is zero. So if we consider this is node A, now there is a 5 current, it is meet in a single node, then that total current is equal to 0. Now we have to identify what are the current potential, that is positive or the negative. Now if any current it is inward current or towards the node, then we can consider the current is negative. So here the current I1 and I2 it is inward. So I1 and I2 it is inward current towards node A. So it is I1 and I2 it is negative. Whereas I3, I4 and I5 it is outward current and from this node. So we can consider that three currents are positive. So I3, I4 and I5 it is outward current and it is from the nodes. So that's why it is these three currents are positive. Now as per definitions, if we solve this figure in KCL, then we can write minus I1 minus I2 plus I3 plus I4 plus I5 that will equal to 0. Now let's start with some example to better understanding what is the KCL. Now here one figure is there, one circuit we draw. Here you can see that nodes A, B, C, D is present. Also there is a difference currents. So here some current is given I1, I2, I5 value is given. We have to find out which current is not given here. So let's start with the node A. In the node A, if we apply KCL at node A, then what are the results? As per definitions, you can see at node A there is a three current I1, I2 and I4. I1 is the inward current that is towards the node, where is I2 and I4 it is outward current. So here I1 is minus, I2 is plus, I4 also plus, that will equal to 0. Now here I1 is given, I2 also given, then we can find out what is the I4, that will equal to 4 ampere. As current unit is ampere, that's why we use the 4A. Similarly, if we apply the KCL at node B, then we can find out the other current also. At node B, how many currents are there? There is a three current. One is I2, I5, and I3. Where I3 is inward current, that is towards the node, and I2 also towards the node. That is these two I3 and I2 both are inward current, and I5 it is outward current. So as per KCL, we can write I minus I2 minus I3 plus I5 that will equal to 0. So from here we can find out that value of the I3 that will equal to minus 2 ampere, because 5 I5 is given 4 ampere and I3 I2 also given, we find out that I3. Now similarly at node D, if we apply KCL at node D, how many currents are there? There is also three current I6, I3, I4. Where is I4 and I6 inward current and I3 is outward current. So I4 and I6 it is towards the node. So it is minus I4 minus I6 plus I3 that will equal to 0. So from here we can find that I6 that will equal to minus 6 ampere. So from these equations we find the three current, unknown current, one is I4, another is I3, another is I6. So using KCLs we can solve others problem also if we know that what are the exact current. There is another example is there. In this example, we have to find out that current through this resistance, 10 ohm resistance, 2 ohm resistance, 5 ohm resistance. So let's start this example again. So here you can see that 15 ampere current apply here, another 5 ampere current apply here. We have to find out the total current in I1, I2 and I3. Now what is the I1? So if we apply that KCL at node A, then we can find that minus 15 because it is inward current plus I1 plus I2 minus 0. So from here we can write I1 plus I2 plus I3 that will equal to 20. So these are the first equations. Now here using Ohm's law we can identify what are the current of each branches. So first one I1 that will equal to total voltage divided by 10 ohm resistance, where I2 total voltage divided by 2 ohm resistance. Another one I3 that will equal to total voltage by 5 ohm resistance. So using Ohm's law we can calculate the I1, I2, I3. Now if we put this value in this equation 1, then what are the equation? V by 10, V by 2, V by 5 that will equal to 20. So from here we find that V equal to 25. So if we know the V equal to 25, we can calculate what is the I1, I2, I3 if we put the V value in these equations. So we can calculate I1 that will equal to 25 by 10, that is 2.5, and I2 that will 25 by 2, that is 12.5, and I3 that will 25 by 5, that is 5 ampere. So using KCL, we can solve this problem also. Next, another important law, that is Kirchhoff's voltage law. It states that the algebraic sum of voltage or voltage drop in any closed path in a network in a single direction is zero. So we consider the voltage drop as positive when current flow from. So if we know the definition of the KVL, we can easily identify what are the total voltage of the circuit and the summation of the total voltage that must be zero. Now we have to identify what are the voltage drop in whenever current flowing from one direction to the another directions. Now current flowing from negative to positive through this network, then we consider it is negative. If current flowing from positive to negative, then it is positive. I repeat again, we consider the voltage drop as positive when current flow from positive to negative potential. So here V1 is negative, V2 is positive, V3 is positive, V4 is positive. So as per KVL, if we apply in this network, so minus V1 plus V2 plus V3 plus V4 that will equal to 0. Now we start one example with one circuit. Now in this circuits we apply the voltage here V1, another voltage we apply V2. So now as per KVL's law, we can easily identify here the current flowing from this point minus to plus, positive to negative, that's mean V1 is negative, and here positive to negative, that V2 is positive. So if we apply the KVL here, then what are the equations? The equations are minus V1 plus here resistance R1 is present and current also I1. So here we can write I1 into R1 that voltage in terms of resistance and the current, that is I1 R2 plus I1 R3 that will equal to 0. So from here we can find that V1 that will equal to I1 into R1 plus R2 plus R3 plus V2. or we can write the V1 minus V2 that will equal to I1 R1 R2 plus R3, or we can write that I1 that will equal to that V1 minus V2 divided by R1 plus R2 plus R3. So using this formula, we can find out the total current inside these circuits. So if we know the voltage value, we know the V2 value, if we know this other three resistance value, then we easily calculate what are the current. Now let's start the another example with some values. So here in this circuit, we use the two different voltage. One is 8 voltage, another is 4 voltage. Now we have to first identify where the current which way it will flow. So here current is I and it is positive to negative. That's mean minus 8V. Here positive to negative plus 2 into I. Here positive to negative plus 2V naught. Here positive to negative plus 4V. Here again positive to negative, then 6I that will equal to 0. So from here we can find out the total current here. But we have to know what is the output voltage. So in another case, you can see there 6 ohm resistance is there, and here voltage is given, that is V naught. So that V naught that will we can write here 6 into I. So this value we can put here, then we can easily find out what are the total current or voltage